He got me a 5. He got me a 5 on a MVC test.
I think you can. You got it.
Oh, thank you, Mr. Parker. Thank you. That actually means a lot.
All right, today we're going to go over integrating powers of trig functions because there's a big difference between integrating the odd powers and the even powers.
Okay.
So you need to fill out that thing that's on the website, integrating powers of trig functions. And you only have to go up to the 6th power because I remember before we used to go up to the 8th power. So like I told you, the first 2 rows, the 1st power and 2nd power, we should know those already. They're on the list. Okay, so let's start with either sine or cosine to an odd power. Now I'm not going to completely do it for you. I'm just going to show you the technique.
Sine to the 5th.
Like for example, okay, sine to the 5th. Now whenever you have sine or cosine to an odd power, it's easy. All you gotta do is break it up into the even power and sine to the 1st. So like if it's 3rd power, you go 2nd and 1st. If it's 7th power, you go 6th and 1st. You know why? Because then you just make u substitution. You let u, because look at this part right there. Isn't that the du for cosine x? Well, opposite, yeah. So if you let u equal cosine x, du will be negative sine x dx, which is that? Well, times negative 1. Yeah, but Mr. Park, if I let u equal cosine x, what am I going to do with that? Just use Pythagorean identity. Isn't sine squared, sine to the 4th x the same thing as sine, cos, what am I saying? Sine squared squared? It's either yes or no, 50-50 chance.
Oh, yes.
And then isn't sine squared the same thing as 1 minus cosine squared x? Again, 50-50 chance. Yes, and then there you go. Just make the u substitution, you're done. So when you have sine or cosine to an odd power, easy. It's just a u substitution. Okay, but then when you have to the even power, then it gets a little tougher. Like let's do cosine to the 4th.
Easy.
See, I am not going to finish this. You guys are going to finish it. And I'm going to take down the answers and I'll just post the answers. We're not going to post the technique because I'm showing you the technique over here. Okay, so when you have even power, you cannot, see, in order to use the Pythagorean theorem, the identity here, you got to have either 2nd, you know what I mean? You have to have a multiple of 2, like 4, 6, or 8, so that you can use this, right? Because that's 1 minus cosine squared. But when it's even like this, there's no du there, so what do? Well, what's the only way to integrate cosine to the, cosine squared? Because cosine to the 4th is cosine squared squared, right? What's the only way to integrate cosine squared?
1/2 plus cosine 2x over 2.
Yeah, 1 plus 1/2 cosine 2x, and guess what, people? You gotta multiply that out.
Huh?
That's how you do it. So what would happen if you had cosine to the 6th power? Then you gotta cube it. Then you gotta multiply it out. And then if it was 8th power, then you gotta raise it to the 4th power.
No.
So that's why odd power easy, even power you get plenty of work to do.
Wait.
Just use the identity that we learned from last year, right? So here, someone going, what you talking about? Well, what happens when you multiply this out? I'll just do one more step then. You get 1/4 plus
1/2.
1/2 cosine 2x. How come all of a sudden now you participate?
Oh, I don't know.
Plus 1/4 cosine squared 2x. And we didn't even integrate that. Now we know how to do that. We know how to do that. And right there, what's the only way to integrate cosine squared? Replace it with the identity 1/2 plus 1/2 cosine 4x. So you can see you get plenty of work, especially when that's 6th power and then that's a cube. Aren't you glad you didn't have to do 8th power?
Yes.
Yeah. Okay, so there you go. Now what about the other ones? Well, if you have secant tangent, cotangent, or cosecant, then the even ones are easy and the odd ones are hard. So let's do an even one. Give me one. Let's do cosecant. Cosecant to the what? 4th or the 6th?
4, 6.
Well, it doesn't matter because the technique is the same whether it's 4, 6, or 8. Yeah.
Couldn't we just find all of them from sine and cosine, or no? Or would that work?
I pretend I just didn't hear
Okay,
that.
never mind.
You mean change that to 1 over
Never
sine
mind.
to the 4th,
Yeah.
and then what?
Alright.
Just take the answer from sine to the 4th and put 1 over that. Like I said, I pretend I didn't hear that. Cosecant to the 4th. Like I told you, if when you have these to the even power, then it's easy. So what do you think I'm gonna do? You're gonna split it up in cosecant squared times cosecant squared. What if this was 6 power? Then you make cosecant to the 4th cosecant squared. Yeah. This is bringing back bad memories from last year.
Pascal.
No, math.
No, you?
Oh.
Why do you want the cosecant squared here?
Oh, the cotangent.
Yeah, because that's the derivative of cotangent multiplied by -1. See, so once you split it up like this, what you're gonna do is you're gonna let u equal cotangent x. Because du is negative cosecant squared x dx. Boom! That's that thing right there. Yeah, but Mr. Park, how do I change that to cotangent then? Pythagorean identity, right? What's the identity for cosecant squared? Ha!
1 minus.
Eh.
I forgot.
Park,
Come again?
1 out of 3 chance. What's the Pythagorean identity for cosecant squared x?
Pythagorean identity. Oh. Cotangent. Squared. X, nice one.
Eh.
Plus 1.
Wang.
Plus 1.
Oh, you sounded like Park.
Thank you.
And see, now you can see how that's gonna work. So you get u squared plus 1, negative du. Finished already. And then of course, what if this were a 6th power? You're gonna split this up into 4 and 2, and then this just becomes cosecant squared squared. But that doesn't bother us, right? So when you have cosecant, cotangent, what did I say, tangent and secant to an even power, it's easy. But then when you have odd power, it gets tough. In fact, we're gonna need the whole board for this one.
Oh.
No! Oh, that was so close.
What?
I'm serious.
Why do you wanna?
Let me take a picture. Let me take a picture.
Okay, let's do secant cube then. Now I'm gonna show you how to do secant cube, but you know, if you're gonna enter your integral B next year, it pays to have this one memorized. I'm gonna tell you right now, this one comes up in multivariable calculus quite a bit. You might want to memorize it. Okay, so here's the technique. So when you have cosecant, tangent, and cotangent to the odd power, then it's tough. So what we're gonna do is we're gonna split it up. Secant x times secant squared x. Okay, so right there, there's like a hint. What do you think I'm gonna do right here?
Oh, the tangent squared stuff. Or like.
Okay, now some of you are thinking, oh, hey, isn't that the du for something? So if I let u equal tangent x, wait, then du is secant squared x dx. But then, so I got the du part, but how do I change that to tangent?
Oh, you can't.
No can. So that's why it doesn't work. Otherwise it would be easy. So anybody else have any other ideas? U substitution doesn't work. What's
What are
the
the parts?
integration by parts? Woo-hoo-hoo-hoo. Let the fun begin. Okay, which one should I let u equal to? The secant or the secant squared?
Secant.
The secant. And then this one is the secant squared. That's because we can anti-differentiate that. That's easy. And what is the derivative of secant? Redeem yourself, Park. Derivative of secant x.
Secant x, tangent x, plus c.
No,
Or
dx.
I
dx.
say, yeah.
So, the integral of u dv, which is the thing we're trying to find, is equal to u times v, secant x tangent x, minus the integral of v du, which is secant x tangent squared x dx. So in order to do this integral, I gotta be able to do this integral. Any ideas? Okay, well, okay, can I erase this now part?
Yep, go ahead.
Thank you, because we need the room. Any ideas on that?
Or change tangent squared.
There you go, you change
Oh.
tangent squared to secant squared, plus 1 or minus 1? 50-50 chance,
Plus.
minus 1. We don't know our Pythagorean identities. So what do we have here? The integral of secant cubed x dx is equal to secant x tangent x minus, now if I distribute the secant, you're going to get the integral of secant cubed x plus the integral of secant x dx. Now this we know that one, right? That's on our list. But what about secant cubed? That's the thing we're trying to find. So what do you think we're going to do? What technique is this?
Oh,
Where I take this and bring it over on this side.
solving
For the unknown integral. So if you bring this on this side, you're going to have 2 integral secant cubed x dx is equal to secant x tangent x plus the integral of secant x, which we know, which is on the list. Wang? Integral secant x dx. What is that cheat sheet that popped up right there? How do you guys do that?
What?
You just press a button and the cheat sheet pops up.
Really?
Yeah, right there. I saw him had it. I saw him there.
Yeah.
Yeah, what is that thing? You
Wait,
just-
you just split screen, you just split
Yes,
screen.
it's good.
But how did you know that was on the split screen?
Because you already had it
Because you already
open.
had it open.
Like right
Yeah.
before you had that.
You just do this and it comes.
Yeah, 'cause I
Yeah.
knew you were gonna call.
How come
me.
that's? Because you knew I was gonna call you.
Still can't find it.
Wait, what do you
Okay,
think?
if you're gonna look at it, if you're gonna look at it, you still don't know what it is. Okay, park.
Wait, what am I saying?
The integral of secant x dx.
The integral of secant x is ln absolute value of secant x plus tangent x plus c.
Okay. And so all you have to do now is divide by 2. So the answer gonna be, this is the way I memorize it. You can just put it all over too, but I like this is the way I memorize it. 1/2 secant x tangent x plus 1/2 natural log absolute value secant x plus tangent x. Because I want to win the integral b. That's why. And then of course when you multiply c by 1/2, it's still c, right? It's a constant. So wait, Wang, you're telling me if you don't have the integral of secant x dx memorized, what the list did Mr. Ye give you a list last year?
Yeah.
Was this on the list?
Yeah.
Because it was my list.
I don't know.
Okay, for those of you who refuse to memorize this, remember how the book taught you to do it last year?
What button?
The book that we used!
Oh.
Okay, this is what, I showed you guys this. If you're not gonna memorize then this is what you gotta memorize. You gotta memorize how to do it. You need to multiply top and bottom by
Oh, the
Cho.
secant x plus tangent.
Oh, see? Secant x plus tangent. Now who's gonna remember that besides Cho?
Just Joe.
Now, why would you do that? Why would you even do that? I mean, who's gonna even remember that? That's so that you just now, you let u equals secant x plus tangent x. Then what is du? Okay, Wang, redeem yourself. Oh boy, wait, let me pick, wait.
Yeah.
So this is Wang. Oh, it popped up over there. Wait, how come the split screen is so small? How come,
No.
that's
you
just
can-
to hide it from the teacher.
You can do it as much as you want.
Yeah. It's like
You can do-
halfway.
No, but when he did it, it was just like a small.
You know, that's
Yeah.
why they didn't pull it all the
But
way
you didn't
out.
pull it all the way out.
Yeah, I only
Oh, so the more you pull out, the
Yeah, no, so you
expand.
can go like
Yeah.
1/4, 1/2, and 4.
Oh, I didn't. Oh, you guys are tricky, man.
Hey, Mr. Park,
That's
good
tricky.
question.
Yeah.
Why is it tangent squared x instead of tan x? Or the...
Because tangent times tangent is tangent squared.
Oh, smart.
Okay, Wang, you had enough time to look at it, so.
Yeah, secant x tangent x plus secant squared x.
Okay, now is that good? Yeah, because look, if you distribute the secant to the top, that's that. That's why it works. So then this integral becomes u on the bottom, that's that. And what is all this stuff right there?
Du.
du. So that's natural log absolute value of u plus c. Substitute that in, boom, that's how you get it. So if you're not going to memorize it, you got to at least memorize this technique, which I don't advise because they guarantee you're going to lose the integral b. This integral b is relies on speed as well as accuracy. All right, so there you go. That's how you do odd powers versus even power. So you got to know sine and cosine has its own category, and then the other four has its own category too.
Wait, you use these for cotangent and tangent too?
Yeah. But tangent cubed is a little bit different. You know, I mean, let's do cotangent cubed then. I mean, okay, no, Mr. Park, I want to figure it out myself. Whatever happened to that?
Wait! Oh, was
Too late.
You're
Cotangent.
hard.
Too bad you gotta watch the video. Okay, what do you think I'm gonna do? I'm gonna split this up into cotangent x, cotangent squared x dx. Now what? What do you think I'm gonna do now? Do you think this is gonna end up like the same thing as solving for the unknown integral?
Oh. Can't you like change it to like secant squared x minus 1? Or cotangent squared x?
Cosecant squared x minus 1.
Yeah.
So Cho said change this to cosecant squared x minus 1. Well, and then what happens? What happens when you distribute the ties? You're going to have cotangent x cosecant squared x. You want to make two separate integrals?
Yeah.
Okay. Minus the integral of cotangent x dx. Hey!
You somebody.
This one's on the list. Park?
Yeah,
That one's on the list.
yeah, I know.
So what is it? Minus.
Negative
No.
ln.
No.
No, not ln, sorry.
No, I mean, minus this.
Huh?
So what do I write next to
Natural log.
minus? Natural log.
Absolute value of cosecant.
Sine x
Oh, wait.
plus c.
Sorry.
Maybe we need to, I've never given a speed quiz for multivariable calculus
Oh, you should do
before.
it.
No, those
Yes,
are-
you.
That's all.
You're-
Are you stupid?
No.
That's 4 points.
We are yeah, I know, but we're multivariable, you're supposed to know this. So I'm just gonna let you sink or swim on,
Okay.
and by the way,
Sink or swim.
this is next week now. And why don't we just do the 2 weeks here? 1, 2, 3, 4. Where are we? Here. This is holiday, right?
Liberty, yeah.
Okay, the test will be here or here, but we're period.
We're on the Wednesday. We're on Wednesday.
No, isn't this extended, these two?
Yeah, it's around Wednesday.
So your test is here then.
Yeah.
So those of you watching this video, remember now, you gotta make arrangements to take it here. And if you don't have a free period 5, 6, 7, or 8, then you better take it there.
Can I get?
Or come in during the extended. Or you can come in the morning, because I'm here at like 6:30. So you could take it 6:30 to 7:40 if you want to. Who's that? Wu?
No, they have period 8.
Lam? Kishi? Oh, they all have period 8
I
free?
don't know about Norton. Find out.
But anyway, you can better, none of this like, oh, can they take it Thursday?
Shit.
The answer is no.
Guys, just need-
Take it sometime during extended. Okay, now what about this one? Who needs to redeem themselves? Park? What do I do with this one?
Oh,
It's staring you in the face.
you multiply it out.
We did it right.
Oh.
It's staring you in the face.
Wait.
You can't get easier. In fact, we're at the level now. We just look at that and write down the answer.
Oh, it's you.
Okay, here. Okay, yes, you will do your substitution, but I think we're good enough. We can just look at it and write down the answer.
You.
No, we're not doing. Yeah, we're just doing it in your head.
Can you figure out?
Okay, look. If you let u equal cotangent x,
Yeah.
wouldn't du be negative cosecant squared x dx?
Yeah.
So wouldn't this be negative u du then?
Yeah.
So wouldn't that be negative 1/2 u squared plus c?
That's too much.
That's
Too
a
much
lot of things.
But
thinking.
we're past these. So what's the answer? What do I write here?
Negative u.
No, we're not doing you. Just give me the thing. 1/2 cotangent squared x. Okay, now if you cannot do that, judging by some of your faces, then do this. You go to the side here. This is the side. Go u equal cotangent x. Du equal negative cosecant squared x dx. So doesn't that integral become the integral of u du negative, which is negative 1/2 u squared plus c? And then now you can write negative 1/2, but what was your cotangent squared x plus c? You know what, let's do some practice then, because maybe some of you are not familiar. Okay, let's do some practice so that you guys can get used to this. What is the integral of sine to the 4th x cosine x dx without making the u substitution? Just look at it and write down the answer.
Sine
Oh.
to the 5th x over 5.
Okay,
What?
1/5 sine to the 5th x plus c.
Yeah.
Oh, that means.
I mean 5x.
Okay.
Oh wait, what?
Yeah.
No, yeah,
Why
but
not
that's correct.
do
Sine to the fifth.
Do you guys see why?
Yeah.
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 See, you can do it.
No, but that's.
It's the same thing, except different. Okay, what about this then? Tangent cubed x secant squared x dx.
Oh, that's.
See, because the key is, if you let u equal to sine, that's the u. Over here, if you let u equal tangent, then that's the du, right?
So 1/4.
Oh.
Exactly.
Okay.
1/4 tangent to the 4th x plus c. Oh, you guys think you're good now?
No.
What about secant cubed x tangent x dx?
Oh, I got this one.
Okay, part. I had it
Oh!
and I lost.
Oh, wait. It's one.
Oh, oh, oh.
1 over.
1 over.
No, no, it's 3. 1 over 3.
1 over
Let's
3.
go! Secant
Oh, okay.
cube x plus c.
Very good. Everybody see that?
Wait, how do you
Yeah.
do that?
Because you split this up into secant squared and secant, because the
Oh.
secant x tangent x is the du part.
Oh.
Oh. See, that's the difference between BC and above BC. These things just come to us. If not, then just do the u substitution and nobody will get hurt. Because it doesn't matter, right? As long as you do it correctly in the test, it doesn't matter if you do it in 2 minutes or 10 minutes. It's gonna be full credit. Oh, I remember what I did the last time we had a class. We had an integral b.
No.
How long ago was that?
So based on your test, then you have seeds. I remember we did it like math counts.
Wait, how
That'd
many
be
people?
fun.
How many
Yeah.
people did you have?
I think we had 6 people in the class.
Oh.
The last time we had like an
Are we doing it
actual.
like at lunch?
So based on your test scores, we have the seedings like this.
Yeah,
Then we make it like math counts. 7 plays 6. That
Oh,
winner
yeah.
plays 5. That winner plays 4, and all the way up to 1. The
Wait,
first
what?
seed.
No, math counts goes like 1, 2, 3, 4, 5.
No,
One-
No,
No.
no, I saw it on ESPN.
It's states.
Oh, national.
Ma-
No,
ma-
it's
yeah.
in states that they do that. It's only when we practice that we did that to
Oh,
save time. But in states they do like that.
that's.
Yeah, so these two play, that winner plays here, that winner plays there, all the way up to 1.
Oh, that's-
But then it's gonna be pretty hard, because what about the 3 people that don't have this class? I know, I'll make you come in during the extended.
Wait, what?
Math counts was like
Oh,
the last
meeting
time I was
Like
good at
me
math.
here? No, I'm not doing that. I'm not doing
What are you talking about the last time we were good?
Yeah, basically.
That's terrible.
Yeah.
Okay, do you guys wanna do it? I think I still have the problems from the
Can you
last
give
time
us
I
an
did it.
example problem?
Yeah, like,
that. Wait, we'll
Oh,
get
like
extra
those?
credit if we win.
Like that?
Extra credit if you win.
no, it's just to see if you'll get bragging rights.
Oh, okay.
Okay, we actually want that.
I can give you any integral, and just whoever can do it the fastest.
Yeah, okay.
You know what, maybe we should just have like a time, because then, who knows, maybe it might take like a whole day for 6 and 7 to even come up with a winner.
What? Is it like best?
Oh,
of three?
in fact, did we do it one year in the courtyard at lunch?
I don't know. Is it year?
I am not doing that.
No.
I think we did.
Count
It was
it.
during lunch, and I remember, I think we rolled out a chalkboard, and then
Why?
everybody was watching.
I am not doing that.
No, this was
for
like
the whole
20
entire
20 years ago, I
school.
think.
Oh, that's not that bad.
Well, that's public shaming.
No, that way everybody can see how proficient you guys are.
Or like how dumb we are.
Yeah.
Actually, we wouldn't be
no one
dumb.
else would know.
Yeah, we wouldn't be
No,
dumb
I bet you
because
Mr.
no one would
Yang
know.
would
Because
no
yeah,
one-
even
no one-
AB and BC, they never learned how to do integrals yet,
Mr.
right?
Yang.
Yeah, that's it. That's it.
Yeah, what about the math teachers who are standing there like?
Yeah, I feel pressured.
It's okay, we won't have them ever again.
Oh yeah, you're right.
Okay, I'll think about it. We should have some kind of competition.
Were you in the interview?
I know, everybody brings in $10.
Oh god.
Not 10. That's
Yeah.
Five.
Oh, and this will get $70 pot. This is a $70 pot.
That's actually.
No.
So, first place will get
Why can't you buy lunch?
$40.
How about first place gets $10 and everybody else gets $10?
No,
that's-
I was thinking this.
Whoa, that's a lot.
Okay, how about
$40?
30,
I don't wanna lose my
Wait, can I get
Five.
at least like $5 back?
25,
Yes, right. You're not supposed to gamble.
20.
Yeah.
This is not gambling because it's based on skill.
It was right. That gives to 80.
You should just give us fake money.
10, then how's that?
You should give us fake money.
But this is your chance. Look, you put in $10,
Can't you just
you
buy
can win
the winner
35.
Yeah, but you no, there's a greater chance for you to lose.
You know?
There's a
But
greater
it's
chance-
based on skill.
Exactly.
No, if it was based on luck, randomness, then that's gambling. This is not gambling
What is it?
because it's based on skill.
What is it called?
It's a prize. It's a prize.
It's betting.
yeah, it's still betting.
Yeah.
Just like when you play golf. You ever heard of this thing called golf?
No.
This thing called golf.
Like when people play golf, like for fun, you know when you get to a par 3 where the hole, you can reach the hole in one shot, then they play like whoever closest to the pin. So everybody puts in like $5, and then whoever is the closest to the pin wins all that money. But it's based on
It's called a shootout, yeah? Shootout.
No, it's called closest to the pin.
It's called a shootout.
Okay, we won't do money. How about everybody bring a candy bar then?
Yeah, let's do that.
And then the winner gets all 7 candy bars.
I don't even like candy bars.
Yeah. That's okay, I won't be getting any.
Never mind, we
But
just,
it should
We
be
can talk about it
fun.
we
this
just, yeah, we'll talk about this.
Hey, Miss
some other
Morgan,
time.
Miss Morgan.
Wait, let me turn off the, let me start uploading the video
Were you in the
first.
integral bee when you were in college?
Our school didn't have, as far,
Oh, Miss
believe
Morgan.
me, but when I was in college, I was terrible at